Hello, I'm Salind Gunratna, registration number 3945. In this video, present the workflow of my distributed order processing system. It built using the Spring Boot and Apache Kafka. The project demonstrates the event-driven architecture process on the data consistency, real-time analytics, and the system resilience. Here the complete technical workflow of the systems. As you can see, it is organized into the four main sections. The producer side is in blue where the data originates. The central Kafka cluster is in orange run, running in Docker. And the consumer side is in green where the processing is happen. And finally, the failure handling mechanism, it's in the red at the bottom. So let's trace the journey of the single loader. It's beginning here, producer service. It is a Spring Boot application. So for this case, I am generating dummy data in from here. So before order is sent, it must be serialized. So we are using the Apache Kafka Aurora for the compact binary format. So first, serializer check the Confluent schema registry to make sure that data follow our order rules. This helps us to make sure that only correct and valid data goes into our system. So once the valid and serialized data, the binary message is published to the Kafka broker into the primary order topic. Moving to the consumer side, consumer service is constantly listening to the topic. When the messages arrive, it uses the schema ID attached to the message to retrieve the correct schema from the registry, allowing it to deserialize the binary back to the Java usable Java object. So next, we are enter the processing logic. So in the happy path, we are processing its success. The data move to the real-time aggregation block. So here the system calculate the running average price all of the order received so far and log that result in the console. However, for the simulation for the failure handling, I simulate the failures for high value orders. If the processing is failed, the flow move down to the retype block logic. Using the Spring Kafka error handler, the system automatically attend to the reprocessing failed message up to 3 times with the fixed backoff delay. If all retypes are exist, we do not crash the application. Instead of, the message is routed down here to the failure handling sections. The toxic message is published to a separate data queue topic. This ensures that bad data is isolated for the later inspection without blocking the main processing pipeline. Now I'm going to demonstrate my implementations. So here you can see I have Docker Compose file. Here I am using the Zookeeper and Kafka and schema registry images. So Zookeeper for the managing the Kafka cluster. And here I will show in the terminal. These containers are running now. Docker PS. So here you can see these three containers are now running Kafka and Zookeeper and schema registries running properly. So here you can see I have two services, order services and consumer service and producer service. So now I'm going to run my applications. Here uh, I'm running the consumer application, and also here we can run the producer application as well. So we have two services, producer services and consumer services. Now here you can see in the console we are printing successfully send the order with the order ID. And come to the consumer side. Here you can see order is new order is received and the order total orders are 7 and print in the average as well. We maximize. So here you can see the order and average we are printing in here. So here you can see this is the live we have got the error. So I am come to the code. So from the producer side in the producer service, here from the producer side, I am generating the random orders and we are calling the send order function. From the send order function, we are sending that topic to the Kafka cluster. So here this is the function for that. When we are initially in the our project, I have created the our schema in here. So make sure that follow the requirement. The order have these field, order ID and product and price. So in consumer side, we are getting that order and get the price. If price is larger than 90, we are raising the error. If not, we are calculating the average. Here you can see that error come from this order. So here you can see the order price is more than 90. That's why we are through the error. So we tried 3 times, but then we send that message to the data queue. Then we are processed with the other orders. Then here you can see we are doing serializations and yeah, here you can see we are receiving the other orders after that. In terminal, we can see sended date later queue messages. Here we are running all the images. So when we are topic is order topic date later queue. So we are check that one. So here you can see there are lot of messages are there in the date later queue. So totally, so here you can see we have 286 messages. So that's how we have handled the errors. Thank you.